We're going to have a really fun exercise in today's guide, and we are going to build out a rock, paper, scissors game. But we're going to do it with a little bit of a twist, and that is that we're going to build it out with the expectation that other rules will eventually be added to the game, which means that we may have other items in addition to rock, paper, and scissors, and we may have some twists, such as one item needs the ability to win over two others. And we're also going to work with randomization. So in order to get the test passing, we just need to build out the basic game, but I still want to discuss the other items. Now also, if you're following along to the point where you're trying to get the test passing, because we're building a computer guessing game, that means we need to have some randomization. And if we're going to have randomization, that means that that can be very hard to test unless we force a certain pattern. So if you look down, say on line 10 and then line 16 and line 22, you can see that we have an attribute called rand seed. So if you're following along and you want to get all the test passing, then you're going to have to add that as an attribute, but I'll discuss that a little bit more later on. So first thing is we have a class, and it's a class called RPS, which stands for rock, paper, scissors. And I'm going to add in that adder writer method, and it's going to be for the random seed. Now, if you're not following along from a test perspective, you don't have to do this part, but it is important for us because if you remember back to when I talked about this before, randomization is not really a real thing in computer science. There's no such thing as randomization because a computer can't think for itself. It has to be told what to do, even when it's attempting to be random. So in other words, if I do random 4 and run this, if I run it right here, this is going to run. The first time it's going to be 0, next time it's going to be 2, then it's going to be 2, and it's going to be 3 the next time. It's going to be a different thing going, up to 4. If I did 500, then it would be doing the same thing. So this is going to be part of it. But now what happens when we have tests? Because when it comes to having tests, it can be very difficult to test when we don't actually know what the behavior is. So in other words, we need to have the guess of paper, but we don't exactly know what the computer is going to guess. And so how are we going to know if we should expect that paper should tie with whatever is given, or if it's supposed to win, or if the computer wins? That can be a challenging thing when we're building automated tests. But thankfully, Ruby has a method called srand where we can actually set the value. So the way that a randomization algorithm works in Ruby with the rand method is you can take a seed file or a seed set of numbers, and based off of those values, it will go and it will generate random numbers. But now if you force the seed to be the same every time, that means that you're going to get the identical results every single time. So if I run this, you can see that it is going to be 37. And when I say 37, I'm saying it's going to be this number right here. You can ignore this number. This is just the return value of srand. But right here, so we called rand 500 and it's 37. What happens if I call it again? It's 37 again. And again, and it's 37 again. So this is how we can force a random process to no longer be random, even though it's being called like that. So that is it. You may wonder why I'm talking about this in a rock, paper, scissors game, and it's because these exercises are not just meant to show you how to build out the basic functionality. There are plenty of guides and blog posts written that will do that. I want to show you a professional way to approach these, which is going to include being able to test these items. And so testing random elements is definitely on the non-trivial side, so I want to make sure we cover that. So now that we have that, you can see that whenever we instantiate a new version of this rock, paper, scissors class, we pass in a named argument called guess. So that tells me that we need a initialize method that's going to take in guess, and then from there I'm going to just store the whatever the guess was. But one other thing to keep in mind, we need to make sure that that has been downcased, because what happens in scenarios like on line 21 where a user enters in scissors, but they enter in scissors with a capital S instead of a lowercase one. If we compare that, then we might get some kind of weird behavior. We want to make sure that all of our comparisons are going to be lined up. So if you call downcase right here, it's going to be downcase for lowercase, in other words, for the rest of the program. So now with that in place, let's talk about how we can generate a computer guess. The first thing I'm going to do is have a randomization algorithm. So this randomization algorithm is just going to be the regular type of algorithm. So it's going to be rand and just a set of numbers. It doesn't really matter what it is. So now if I call this, so if I say RPS equals RPS.new with a guess of being rock, and then call RPS to see what the randomization value is. The first time that it gets run, we'll see it's 511,000 and some. The next time it runs, it's 1,088,000. And if we keep running it, it's going to be a different set of numbers pretty much every time. So that's working. Now, technically, we could have called this inside of this next method, but I'm going to show you why I didn't here in a second. So now I'm going to create a method called computer guess. Now, inside of this, this is where I'm going to force the seed. So I'm going to say srand, and then I'm going to pick up the value up from line 4. So I can say rand seed or the randomization algorithm. So what in the world am I doing here? Well, with this computer guess, what I want to do is I want to say if somebody sets the rand seed, in other words, us in our test, if somebody sets this, then I want you to use a seed of our test. But if somebody doesn't, so in other words, if no one sets rand seed, so if this is nil, then I want you to call the randomization algorithm and take in whatever value that is. So the cool thing about this is, let's watch this and now call computer guess. Now if I run this without setting it, you can see we have this giant number. If I do it again, have another giant number, and again, same thing. It's a different number every single time. Now if I call RPS and then I set the rand seed, so if I set that equal to 1, now watch what happens. Oh, and actually I forgot one thing. So now if I come here and, not in the randomization, now if I come here and call rand, then, call rand whatever, so rand 10, now let's see what this returns. Running it, first time it's 5, next time it's 5. Next time it's 5. It's going to keep on being 5. Now if I pull this out and run it again, you can see it's 2, it's 7, and it'll keep on being something relatively random, and it's going off of this randomization algorithm now because we didn't set it. So I know that seemed like it was a lot of work just for being able to manage the randomization, but that's necessary because if not, we wouldn't have been able to properly test the system. So with all of that in place, now we can actually finish out our computer guess. So now what we can do is say computer guesses, set this equal to an array of strings. So I'm going to use the %w and say rock, paper, scissors. And then from there, I can say computer guesses dot sample. So what this is going to do is it's going to pick a sample of one of these items each time it gets called. So now let's run this a few times to make sure it's working for a normal case. So first time we call it, it's paper. Second time it is paper. Next time it's rock. So we know that it works from a randomization point of view. Now if I do our ran seed to make sure that we can actually control this, and I'm setting it to 1. It doesn't have to be 1, but it's just an easy example. Paper, running it again, it's paper. I could run this a million times. It's going to be paper every time because we are the ones controlling the starting point for the application. We're saying that we want the seed to be 1, and from that point on, it's always going to start at the same point. So that is exactly what we need right there. Okay, so now that we have our computer guess and we have our randomization algorithm, now we can actually start to build out the flow. So I can say def, and if you look down on, say, line 34, you know we need a method called winner is. And this is where all of the logic is going to occur in regards to being able to decide if the computer wins, if you win, or if it's a tie. Now, I have seen countless rock, paper, scissors implementations that are really bad because they simply are going through and they create this set of conditionals that check to see, and they just say, okay, if rock is called, then if the computer calls paper, then the computer wins. And it goes through literally every step. Now, that may not seem like a huge deal when it's rock, paper, scissors. However, every single time you'd add in a new parameter. So there's a variation of the game called rock, paper, scissors, spork, something else, and there's all kinds of different variations. And usually in a coding interview, they won't ask for a basic rock, paper, scissors. They'll ask for a system that can actually accept more than just 3 possibilities. And so I want to show you what I think is probably the best way of doing this, because it's a way of being able to build a guessing game and to be able to actually establish a rule engine. So this rule engine is going to be able to decide which values win and which values lose, and we're going to leverage the hash data structure in order to do that. So I'm going to create a new method called rule engine, and inside of this I'm going to create a hash. So the first is going to be rock, and then it's going to have a value of scissors. And then the next one is going to be paper. And this one is going to have rock. And then next one, last one is scissors. And the value on this one is going to be paper. Now, if you've never seen rock, paper, scissors built like this, it's because I haven't seen an implementation quite like this, but I actually like it, because what we have essentially done here is we've made any kind of combination possible. The key is always going to beat any of the items that are in the value. So rock beats scissors. But say you added something else. Say you added mountain, and for some reason mountain could be beat by a rock. Then our rule engine only takes that one change. We don't have to do anything else besides that. So this is a much easier way of scaling this up, and say that we do have that other one, the spork, and spork beats whatever kind of parameters inside of it. We only need to make this change in one spot, and then we don't have to create this crazy conditional. Instead, we can simply build it out and check the rule engine. So from here, I can say if the rule engine, and then pass in computer guess, and it's computer guess, not guesses. So computer guess, pass it as a symbol. And the reason for this is because we're performing a lookup. Remember, the rule engine returns a hash. So let me just really quick, because in case that part seems a little bit weird, let's just come take a look at this. I'm going to get rid of the random seed and the computer guess, and now let's talk about what this rule engine gets us. So the rule engine by itself should return a hash, and it does. So you can see our rule engine works. And now if we want to parse one of these, so say that we want to, grab one of these items, we could say, rock, and pass that in, or I should say you think you could, but even though we set it as a string, in order to actually capture that, we need to convert this to a symbol. So we can just cast it to a symbol like this. Now if I run it, now this is going to return scissors. Now if you're wondering why that is, the key is on line 29. Notice how when we return the hash, notice that rock is not a string. It's actually a symbol. So we just need to cast it to a symbol and that will work. So that's what we're doing right here in our check. So we're saying if the rule engine, computer guess, and casting it to a sim, include the guess, so in this case it would be rock, then we're going to say computer wins. And then we can say else if rule engine, and then pass in guess to symbol, include computer guess, as you may have assumed, and we can say you win. And then else, we can just say that it's a tie. Okay, so this is kind of cool. This is everything that we need, at least I believe so. So now we have our game. We're guessing rock, and now let's actually see who the winner is. So here we can say RPS dot, and then say winner is. And every time, and remember, we're not seeding it right now. So right now, the computer wins. If we play it again, it's a tie. If we play it again, it's a tie. Play it again, and the computer wins. Now, at the moment, I don't have the value that it's pulling, but if you want to look on line 17, you can see right here that this time it guessed paper. And if you wanted, you could always store this in some kind of attribute if you wanted to print out something like the computer guessed and then whatever the value is, whether it's paper, rock, scissors. That part really it's not a huge deal. You just grab computer guess. So you could, just in case you want to see it, you can say RPS dot computer guess, and we could just keep running this. So when scissors gets played, or when the computer plays scissors, you win when you guess rock. When it's a tie, and actually it looks, if on line 17 you can see that it actually returns the three values. So if you look at line, there you go, scissors, rock, and rock. So you can see that what it's doing, I just looked all the way to the left, it actually is giving all three options, and it's bringing up the one. That's how the sample process is working. So here, our computer guess, when it says scissors, that's not actually the most accurate. We would need to pull in what the real guess is, not just the first one, or else we're gonna have some weird behavior. So running that one, you could see it gave a rock, and it was a tie. In this case, it's a rock, and that was the sample that got pulled out of that one, and that's a tie again. You can keep on playing it, and this one was paper, as you could see there on line 17, and that worked. So that's all well and good. That's working. Let's come down though now, and let's test it out when we force it and we have a little bit more control over our randomization. So if I now come and open up our tests, run RSpec March 26th, running this 3 examples, 0 failures. So let's just take one last look at what's going on right here. So we're setting the seed, so we're going to know about the randomization at each level. So it's always going to be paper, and whenever it's paper, we're going to have rock win, and the computer wins because paper is guessed. Next one is going to be scissors, and in this case, you win. And the last one is paper. When you guess paper and the system guess paper, it's a tie. So that is how you do it. And the cool thing that I like about this one really comes down to the rule engine right here. This is, to me, the most powerful part of it. Even though it's so simple, this gives us the ability to not have a huge set of conditionals. We can simply check, is this item the key? Is whatever is being guessed, is that included in the set of rules? So in other words, whenever this is called, is this going to win or not? So that is how I would build rock, paper, scissors.